Today we're going to talk about the law of cosines, and then we're also going to talk about area of triangles using a formula other than just 1/2 base times height. So just like I did with the law of sines, I'm going to go ahead and derive this. I'm just going to make a triangle here. This is going to be A, B, C, which makes this A, B, and C. I'm going to again introduce a segment in here so that I have right triangles, because we have lots of things we can do with right triangles. So I'm going to call this H again. I'm going to go from here to here. I'm going to label that X, which means if this is A, the whole thing's A, this distance is A minus X. Okay. So the derivation of this one, we start with the Pythagorean theorem. Okay, we're going to do the Pythagorean theorem on this triangle here. So C squared is going to equal A minus X squared plus H squared. So I'm going to go ahead and FOIL this out. So we're going to have C squared equals A squared minus 2AX plus an X squared plus an H squared. Now I did the H and the X's in red because ultimately I want to get rid of those and replace them with things in terms of A, B, and C. So the first thing I can do is the other half of this triangle, I can do the Pythagorean theorem. So B squared is going to equal X squared plus H squared. So this can get replaced with B squared. So the last thing I need to get rid of is that X, and it's called the law of cosine, so let's go ahead and throw a cosine. We're going to do the cosine of angle C. Cosine of angle C is going to be adjacent over hypotenuse. So that's going to be X over B, which means X is equal to B cosine C. So we're going to have C squared equals A squared minus 2AB cosine C plus B squared. We rearrange this a little bit. A squared, move this B squared minus 2AB cosine C. So the law of cosines is C squared equals A squared plus B squared minus 2AB cosine C. Now the letters can be anything. You can have a triangle XYZ. The key is you're always going to be solving for either this or this. So side C or angle C. So you either have all the information on this side, which would be two angles and the side in between them, or you have all three sides and you're solving for the angle. You will need to know two sides to do this. Okay, so again, the two cases, or if you have SAS, so that's where you're going to have C, A, B, C. So you know A, you know B, and you know C, and you use the law of cosines to find the third side, or you have S, 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 where you know the three sides. You have that side, you have that side, you have that side. That's what we're solving for. So let's do an example. We're going to solve triangle ABC if angle A is 39.4, side B is 12, and side C is 14. So we're going to draw a triangle just to organize ourselves. I'm going to label it ABC. So A is given to us, 39.4, side B is 12, and side C is 14. So this is side angle side. We are going to be using the law of cosines, and it should be apparent that we don't have enough information to use the law of sines, so we have to use the law of cosines, because I have that angle, not that side, these two sides, but not the angles opposite them. So in the law of cosines, even though in the given our angle was C, here it's going to be A. It's always going to be solving for the side opposite the angle. So in the law of cosines, we're going to have A squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times the cosine of 39.4. Now you're going to type this all into a calculator as you see it. Don't try to chunk it into parts. So we type it all in as we see it, hit enter, and we get 80.36. So we're saying we have the side 14, 12, and 80? Nope. That's what A squared is, so we're going to take the square root of that. So our third side here, rounded to the nearest tenth, would be 9.0. So A is 9.0. So we are solving this, so I'll go ahead and put my grid here. So my given information, 39.4 we have, 12 and 14. We now know A is 9.0. Now I have enough information to use the law of sines, because now I have an angle in its opposite side. There is a catch, however. We're going to use the law of sines, but there's an issue. So my note here is, when using the law of sines, leave the biggest angle for last, because we know from our inverse lesson and from our law of sines lesson that if we do inverse sine, our answer will always be acute from the triangle, even if it's not an acute angle. So this is a unique solution. There is not necessarily going to be an obtuse angle, but if any of these angles is obtuse, it's going to be the one opposite the C. So I'm going to leave this angle for last, because if it's obtuse, we'll get that answer by subtracting from 180. So I'm going to find B next. We'll use the law of sines. So we're going to have sine of 39.4 over 9 equals sine of B over 12. And then our same math we've been doing. So we're going to divide and do the sine inverse. Okay, type that in the calculator, and we get B is 58.2. Then for my last one, we just subtract from 180 to get 82.4, which wasn't obtuse, but had it been, it would have come out in that calculation. All right, so our second example, we're going to solve triangle ABC if A is 19, B is 24.3, and C is 21.8. So we have A is 19, B is 24.3, and C is 21.8. Okay, So in the law of cosines, we're either solving for the third side, which we just did, or in this case, we're going to be solving for the angle. We can choose any of the angles to find, but whatever angle we want, this has to be the side opposite that. So I'm ultimately going to be solving this triangle ABC. We know A is 19, B is 24.3, and C is 21.8. We can solve for any of them. We can start with A, we can start with B, we can start with C. As a rule, I'm just going to tell you, leave the biggest one for last. Law of cosines will work with obtuse angles. So if you want to start with that one, that's fine too. But it just makes an easy decision of, I'll find that one last and we're good. So I'm going to go ahead and start this one by finding angle A, which means if I'm finding angle A, the 19 needs to go in that position. The other two sides are interchangeable. And in this case, we are finding A. So 19's over here, A's over here. Here we're going to have a little bit more algebra to go through to find A. We can't just type it in the calculator. Okay, so order of operation, I'm going to subtract these two things. So we're going to have 19 squared minus 24.3 squared minus 21.8 squared. That leaves me with, on this side, negative 2 times 24.3 times 21.8 cosine of A. Then I'm going to divide by all of this. So cosine of A is going to equal this, 19 squared minus 24.3 squared minus 21.8 squared, all over negative 2 times 24.3 times 21.8. Our last step then would be to take the cosine inverse. So A is going to be cosine inverse of all of that. So we'll type this all in the calculator. So if you have an 84, you're going to do second cosine, then use the fraction. If you don't, then you're going to need to put parentheses around the top and parentheses around the bottom. Otherwise, you're not going to get the right answer. So we got 19 squared minus 24.3 squared minus 21.8 squared all over negative 2 times 24.3 times 21.8. And we get 48.3. So my angle A is 48.3. That leaves us with B and C. We said we're going to leave B for last, so we're going to go to C. For C, now that I have this 48.3, I can use the law of sines. Or you could repeat this for C, that's fine too, but law of sines tends to be easier. So I'm going to have sine of 48.3 over 19 equals sine of C over 21.8. 21.8 sine 48.3 equals 19 sine of C. And we'll divide and take the sine inverse. Okay, so when we type all of that in the calculator, we get 59.0. Then for our third angle, we will subtract from 180, gets us 72.7. Okay. In the notes, in the PDF version of the notes, there is another example given side, side, side. So feel free to practice on that. I'm going to go ahead and move on to area. So in geometry, you did area of triangles, 1/2 base times height. We have additional formulas beyond that. So the first one we're going to look at is if we have SAS. I'm going to draw a triangle here. Okay, so if this is angle B, this is side B, and I'm going to go ahead and put a H in here. Okay, so we know the area of this triangle is 1/2 the base of the triangle, which is B in this case, times the height of the triangle. Okay, well this height, if I go over here, this is A, this is C. If I take the sine of C, that's going to be H over A. So H is going to equal A sine C. So in this formula, my area is going to equal 1/2 B A sine C, or 1/2 A B sine C. So this is our first formula. Again, if you have side, angle, side, we'd have the two sides A and B and the side in between that. So here we have a triangle, and we have two sides and the angle included. So this area is going to be 1/2 10 times 12 times the sine of 33. We type that in the calculator and get 32.7. This is area, so this would be units squared. So it's just another way that we can find area if we have information that's other than base times height. The next formula is something called Heron's formula, and I am not going to derive this one. This derivation's a little bit complicated, but this one's area, and it's going to look really challenging, but it's really not. So we're going to have the square root of S minus A, S minus B, S minus C, where S is the sub-perimeter, which is going to be half of the perimeter. So the A, B, and C are the sides of the triangle, so the sub-perimeter is going to be half of A plus B plus C. All right, so we'll go ahead and do an example of this. So we have three sides, so we use Heron's formula. Our sub-perimeter is going to be 1/2 5 plus 6 plus 9, which is going to be 10. So our area is going to equal the square root of 10, 10 minus 5, 10 minus 6, and 10 minus 9. Use our good old trusty calculator to get an answer of 14.1 units squared. So Heron's formula is a nice one because if you can measure the three sides of a triangle, you can find its area. You don't necessarily need its perpendicular height. So that is the law of cosines and a few alternative formulas for area.